Number one, let's just simplify this radical. So you look, and the index is 3. So that means you can pull them out, but you got to pull them out in groups of 3. You got to have at least 3 of them built up. So this one is actually pretty nice. All you need to do anytime you come across a number underneath the radical, let's do its prime factor. So 54 can be rewritten as 9 times 6, and 9 is 3 times 3, and 6 is 2 times 2. So we're going to rewrite this. So move number 1, we're just going to copy and paste, but don't forget the 7 out front. 7 times the cube root of 3 squared and 2 squared. I think I messed up. It's not. I don't think it's going to be 2 squared. Because where I messed up is right here. 6 is not 2 times 2. 6 should be, instead of 2 times 2, it's a 3 times a 2. There we go. So we're actually going to have 3 of these 3's. And then times only one of the 2's. Now let's just copy and paste the variables. M to the 4, P to the 7, Q to the 6. Okay, now let's just go through each item one at a time and see if we can pull some things out. So on the outside you've got a 7. Anything you pull out, you're going to multiply it. So the index is 3. So how many 3's are in 3? There's one of them. So I'm going to pull 3 to the 1 out. He's done. No left over. 2's. I don't have enough 2's built up, so my 2's are going to stay in. So I'm going to put a 2 there. 2's are done. M's, I've got 4 of them. I can pull out a group of 3. If I pull out one group of 3, so it's going to be M to the 1, that's going to leave me on the inside with 1 left over. And I don't even really need to write these 1's. So my M's are done. P's, I've got 7 of them. I can pull out groups of 3. So how many groups of 3 are there in 7? There's 2 of them. So I'm going to pull out P squared. And 2 groups of 3 is 6, so that leaves me with 1 left over. And my Q's, 6 of them. Pull out groups of 3, I can only pull out exactly 2 with no leftovers. So on my outside, I'm going to have a 7 times 3, so I've got 21 M P squared Q squared. And on the inside, I've got a 2, an M, and a P, and that is your answer. Number 2. Okay, this one's a multiplication problem, so let's multiply first, and that will be our move number 1. So on the outside I got a 2, and on the outside of here I've got a 1. So multiply your outside coefficients. 2 times 1 equals 2. And let's multiply everything on the inside together. So 15 times 20, they're both underneath the radical. 15 times 20, what is that? Is that 15 times 20? It's 300. Alright, so 300, and then x cubed times x to the 1 is x to the 3 plus 1. When you multiply powers, when you multiply these variables, you add the exponents. So it should be x to the 4. Okay, now I'm going to write the prime factors of 300. That's 100 times 3. That's 10 times 10. That's 5 times 2. 5 times 2. Done, 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 done. So move number 2. On the outside I've got 2. On the inside, let's see, how many 5's do I have? I've got 5 squared times 2 squared times 3 times x to the 4. And the index, there is no number, so it's understood to be a square root. So that's a 2. So I can pull out in groups of 2. So now my last step, on the outside I've got a 2. Let's see if we can pull some things out. I can pull them out in groups of 2. So I've got 5 squared. How many 2's are in 2? Pull out exactly 1. I've got 2 squared. How many 2's can I pull out? Exactly 1. So those are done. Those are done. 3's, I only have 1 of them. So he's not enough to come out. He stays under. X's, I've got 4 of them. So groups of 2, I can pull out 2 of them. X squared, he's done. So on the outside, I have a 2 times a 5 times a 2. 2 times a 5 is a 10. 10 times a 2 is a 20. X squared times the square root of 3. Final answer. Number 3, same thing, multiplication problem. On the outside, I don't have anything. I've got a 1, I've got a 1. So if I multiply, on the outside, I'm going to have a 1, and you don't even need to write that. Underneath, you are going to have 2 times 3, that's 6, times x squared times x to the 1 is x to the 2 plus 1. So you are going to have, if I break down 6, that's going to be 3 and 2. You are going to have 3 to the 1 times 2 to the 1 times x to the 3. You add the exponents. There's no index, so it's understood to be a square root. I could pull them out in groups of 2. I do not have enough 3's. I do not have enough 2's. I do have enough x's. So my last move, if I've got 3 x's and I can pull out a group of 2, I can only pull one group of 2 out. There's going to be 1 left over. And I'm just going to write 6. I'm going to multiply my 3 and 2 and call it good. Final answer. 4. Okay. It's a fraction. So can I simplify my outside coefficients? 4 and 5. Can you divide them by a common factor? No. What about my inside? 5 and 2? No. So you're done. Except for this is illegal. You cannot have a radical in the bottom. I cannot have a square root of 2. So you're going to multiply this by 1. And I'm going to multiply it by, my 1 is going to be the square root of 2. This guy, that's your problem. Because if you times it by itself, a square root of 2 times the square root of 2 equals a square root of 4. So that's going to be underneath. On the outside, I've got a 5 and a 1. So 5 times 1 is going to be 5. Okay, now on top, underneath, I've got a 5 and a 2. So multiply those, it gives you 10. Bring your 4. And now you have multiplied both the top and bottom by square root of 2. So you multiplied it by 1. You haven't changed the value, but you can clean it up, because now, because you did this, you multiplied it by itself on the bottom, you created a perfect square. Square root of 4. Square root of 4 is really a 2. So on the bottom, you have really got 5 times the whole number 2. Or you have got 10. Okay, now, you're not done yet, because on the outside I've got a 4, and on the outside I got a 10. 4/10 is a fraction that has a common factor, a GCF of 2. You can divide them both by 2. So if you divide 4 by 2, that's going to be 2. If you divide 10 by 2, that's going to be 5. This is the best answer right here. That's what you hand in. 5 is also a fraction. Okay, 3/4. Can you simplify 3/4? No, you can't. Underneath, can you pull anything out? 5, I only have 1 of them. M, I have 1 of them. Okay, this guy right here should catch your eye. The index is 2. It's a square root, and you've got 4 m's. So how many of those m's can you pull out? If your index is 2, you can pull them out in groups of 2. So move number 1, let's pull some 4's or some of those n's out. So on top you're going to have 3, on the bottom you're going to have 4 n squared. You can pull 2 groups of them out perfectly, no remainders. Square root of 5m. Okay, that looks a little better. Now, you're ready to hand it in, except for this is illegal. You cannot have in the denominator a radical. So it's an easy fix. You just multiply it by itself. So the radical is 5m, square root of 5m. So I multiply the top and bottom by a square root of 5m. Okay, now let's do the top first. On the outside you got a 3. On the outside of here you got a 1. So 3 times 1 is going to be 3. And then times the square root of 5m. On bottom, outside is 4n squared, outside is 1. So you're going to have 4n squared. But now here's what is awesome. Underneath, if you do 5 times 5, that's 25, which is a perfect square. And your letters, m times m, that's m to the 1, m to the 1, it's going to be m to the 1 plus 1. So it's going to be m squared. Now you strategically created this because it's going to clean up. On top you're going to have 3 times the square root of 5m. On bottom you're going to have on the outside 4n squared times the square root of 25 is a whole number 5, and the square root of m squared is just m. So your final answer on top, you've got 3 times the square root of 5m. On bottom, 4 times 5 is 20 mn squared. Done. Okay, your last fraction, number 6. Okay, let's see if we can clean up a 3 and a 2. No, a 3 and a 2, no. But yes, on your variables, you can clean these up. Okay, I've got x to the 4th on top, and I've got x to the 1 on bottom. This x to the 1 on bottom is going to cancel one of these x's on top. So instead of having 4, I'm going to have 3. And same with my y's. This y to the 1 on bottom is going to cancel one of the y's on top and leave you with 3 y's. Okay, now they're both square roots, so you have to pull out in groups of 2. And on the top, I do have enough x's and y's built up, I can pull some out. So on the outside I got a 3, and let's see, on the inside that 3 is going to stay put, not enough to come out. But in groups of 2, and if I have 3 x's, I can pull one group of 2 out, and that's going to leave me with 1 left over. Same with my y's. There's one group of 2 and a 3, so I can pull 1 out, and then there's 1 left over. So your numerator now is going to look like that. 3xy on the outside, square root of 3xy on the inside. Okay, underneath you are just going to have 2 and the square root of 2. And you can't simplify anything, but this is illegal. You cannot have a square root of 2 on bottom. So if you just multiply it by 1, there's 1. I'm not changing the value, so I'm doing everything legal. But now you will, on the bottom, you are going to create a perfect square. Square root of 2 times square root of 2 is square root of 4. And on the outside you got 2. Okay, up top you are going to have on the outside is just 1 and 3xy, so you're going to have 3xy. But these things underneath you multiply together, so you're going to have 3 times 2 is 6xy. Then your last step, just clean this up. What is the square root of 4? It's a 2, so you really have a 2 times a 2. So on bottom you got 4. On top, 3xy times the square root of 6xy. Done. 7. Alright. If you have a fraction for an exponent, move number 1, let's rewrite it as a radical. Okay, your denominator goes in the index, and I'm going to copy and paste this whole mess in parentheses, 216 m to the 9, and my numerator is going to be the new exponent right there. Okay, sweet. Now nothing new. Anytime you got a number underneath the radical, let's do prime factors. So 216, if I divide it by 8, it's going to be 8 and 27. 8 is 4 and 2, 2 and 2. So done, done, done. 27 is 3 and 9, that's done. 3 and 3. Alright. Now, maybe I'm going to come over here. I am going to write the cube root. Instead of 216, I'm going to swap it out for, I've got 2 cubed and 3 cubed. And then I've got m to the 9. That is all in parentheses and to the 4th power. Okay, now this 4th power needs to be taken to each factor on the inside. And if it already has an exponent and you're raising it to another level, here is where you multiply them. So you are going to have the cube root of 2 to the 3 times 4. It's going to be 12. 3 to the 12, and m to the 9 times 4 is 36. Okay, your index is 3, so I can pull them out in groups of 3. If I've got 12, I know that there's 4 groups of 3 and 12, so it's 2 to the 4 on the outside, 3 to the 4 on the outside. How many groups of 3 and 36? There are 12. Okay. The next thing you could do is change this to a 16 times 3 to the 4th is 81. So if you express it as a number, it's going to be 1296 m to the 12. Number 8. Okay, this one's easy because it's 100% algebra, no arithmetic. So let's convert it. Because I see the fraction for an exponent, here's what I know what's going on. That 2 goes there, the 3 is going to go here. And then I just copy and paste the parentheses and squared right there. Okay, move number 2, I need to take this 3 into there and I multiply them. It's power of a power, so it's going to be the square root of n to the 6. Pull them out in groups of 2. How many 2's are in 6? Your answer is n cubed. No left over. They all come out. 9. This one was probably a little tricky because of the negative. So, you cannot have a negative exponent. Anytime you come across a negative exponent, you are really dividing. So I'm going to put it under 1. So I'm going to write 81 r to the 6th to the 3 halves, and now it becomes positive. So now I'm legal. You cannot have any negative exponents. Move number 2, let's write, to keep the fraction, let's write a radical. That 2 is going to go right here, and the 3 is going to be the exponent of 81 r to the 6th in parentheses. Okay, let's break up 81. 9 and 9, 3 and 3, 3 and 3. I'm going to come over here. Let's rewrite this as 1 over square root. In place of 81, I'm going to swap out 3 to the 4, r to the 6, and that all is raised to the 3rd power. So now you got to take the 3 to everything and you multiply them. So it's going to be 1 over square root of 3 to the 12, r to the 18. Okay, now you can pull them out in groups of 2. So it's going to be 1 over, how many groups of 2 and 12? There's going to be 6 of them. How many groups of 2 and 18? There's going to be 9. And you're ready to hand that in. But you could, this would be better, if you trade 3 to the 6th for 729, that is the best answer right there. Okay, 10. This one is pretty cool. X squared times x cubed equals x to the 2 plus 3 equals x to the 5. So all you do when you have powers, you add them. If you're multiplying powers, you add the exponents. So this is going to be x to the 2/3 plus 5/3. All you do is add those. So it's going to be x to the 7/3. You know, that's halfway right. Then the instructions say write it as a radical. So now let's convert it to a radical. The x goes here, The 3 goes there, and the 7 goes there. So the index is 3. You can pull them out in groups of 3. Do you have enough x's built up you can pull some out? Yes. 7, there's 2 groups of 3. So I can pull 2 groups of 3 out, and I am left with 1 left over. That is the best answer. X squared times the cube root of x. Okay. I'm not going to go over this one. It's in your notes. So just copy and paste in your notes. You need to have the naturals, the wholes, the integers, the rationals, the irrationals, and the reals. You got to explain each set. Checkerboard. How many squares are in a 10 by 10 checkerboard? We know that there are going to be 100 little checkerboards, or little squares. The 1 by 1 squares, there's going to be 100 of them, and I get 100 from doing 10 times 10. Okay, the 2 by 2 squares, there's going to be 81. I get that from doing 9 times 9. The 3 by 3 squares, there's going to be 64. I get that from doing 8 by 8. The 4 by 4s, there's going to be 49. I get that from doing 7 by 7. The 5 by 5s, there's going to be 36. Get that from doing 6 by 6. 6 by 6s, there's going to be, what are we on, 25. Get that from doing 5 by 5 times 5. The 7 by 7s, there's going to be 16. 4 times 4 gives me 16. The 8 by 8s, there's going to be 9 from 3 times 3. The 9 by 9s, there's going to be, how many is there going to be? 4 from 2 times 2. And if I look at one big square that measures 10 by 10, it's going to be just one of them, and I get that from doing 1 times 1. So if I add all of those up, 181, 64, 49, 36, it's going to leave you with 385 squares. Number 3. What number times itself 3 times is a negative 1? That's what this is asking. What number multiplied by itself 3 times is negative 1? The answer is negative 1 multiplied itself, negative 1, 3 times is going to give you a negative 1. Number 4 is asking what number times itself 4 times, because that's the index. 4 times is going to give you a negative 1. Okay, this one is impossible, because if I do negative 1 multiplied itself 4 times, the answer is not a negative 1, the answer is a positive 1. And if I do positive 1 times itself 4 times, let's see, that's 4. The answer is 1. So there is no way that you can multiply any number over and over again 4 times and have your answer be negative. Your answer will always be positive. If you repeatedly multiply an even number of times, your answer will always be positive. So positive times a positive over again is always positive, but a negative times a positive, or a negative times a negative, an even number of times is a positive. So that's positive, a positive times a positive is a positive.